In this example 10, we are going to integrate e power x cos x using integration by parts. However, you will find out that later, in order to perform integrations of e power x cos x, you have to also integrate e power x sin x if you are using integration by parts formula. The integrations of either this one or this one will necessarily generate the integration of the other term. Let's see what I meant by that. So I'm going to integrate e power x cos x on the left and integrate e power x sin x on the right hand side. We will be doing this concurrently. So on the left hand side, I'm going to choose my u to represent e power x, and I'm going to choose dv to represent cos x dx. So du will give me e power x dx. Integrating dv will give me v, which results in sin x. So integrations of e power x cos x dx in the method of integration by parts is written as uv minus v du. Here u is e power x, v is sin x, minus v, which is sin x, du is e power x dx. On the right hand side, I'll choose this to be pq minus q dp, where here I'm going to choose my p to represent e power x and dq to be sin x dx. Differentiate dp, give me the differential of p, which is ex dx. Integrating dq give me q, which is minus cos x. As a result, the integration of e power x sin x dx is then expressed as the product of p, which is ex, q, which is cos x, with a minus sign, minus integrations of q, which is a minus cos x, and dp, which is just ex dx. So now you can see clearly that the integrations of e power x cos x results in the integrations of sin x e power x, whereas the integrations that involve e power x sin x requires the integration of cos x e power x. I'm going to call this equation number 1, and I'm going to call this equation number 2. You can then obtain the integration of e power x cos x by manipulating equation 1 and equation 2. Specifically, if you were to take equation 1 minus equation 2, here this term will minus the right hand side of this term. It will give you a factor of 2 e power x cos x dx. And the right hand side would be e power x times sin x minus this, which will end up to have a positive term, which is e power x cos x. So you take this factor over, and since we are performing an indefinite integration, therefore you have to have a constant on the right hand side. So that is how you obtain the integrations of e power x cos x. So the conclusion is, if you were to calculate the integration of e power x cos x using integration by parts formula, it is necessary for you to also perform the integration by parts for the integration of e power x sin x. Then you combine the formula for both integration, you'll be able to arrive at the integration of e power x cos x.